Okay, let's give you guys some more practice. So find the radius of convergence and the interval of convergence for this power series. So press pause and have a go. Okay, so to do this, we're going to use the ratio test. So when it comes to the ratio test, we always need to compute this value here. Get an plus 1 divided by an. So this is your an plus 1 divided by an is the same as multiplying by the reciprocal of an, which would be this. So now tidy this up. So visualize this as 2 to the power of n times 2 to the power of 1. And then visualize this as the exact same thing to the power of n, exact same thing to the power of n, and then exact same thing to the power of 1. That's so here you've got n plus 1. Here you've got n plus 1. And then what, let me think. And then that's it. And then this will then cancel out with this. This would then cancel out with this. That would then leave you with a 2 here, which is this 2, and then x minus 3, n to the power of 2, and then this thing here, this thing here. So from here, that will then take you to here, and then group all the n's together. So group all the n's together, and then move this over here. So that will then give you this. So group all the n's together. That will then give you this. So from here, remember apps of a times b. That's the same as apps of a times apps of b. So looking at this. So imagine this as being apps here and then apps here. So that this thing here will then become this. This thing here will then become this, and then well, if you look at this, n is always moving from what was it? N was from hang on, let me think. N is always moving from 1 to infinity. So hang on. So n is always moving from 1 to infinity. So n is always positive. N is always positive. If n is always positive, then n squared will be positive. This thing here will be positive. So you don't really need the absolute here. So you can discard the absolute. You can discard this absolute. So this whole thing here will then become this. And then you've got one thing multiplying with another thing. So take the apps of this thing, take the apps of this thing. That will then give you this. Well, the absolute value of positive 2 will always be 2. So this thing, well, from here, that will then take you to here. And then, so remember, with the ratio test, we always need to compute this value. So if this value here is less than 1, we know it's going to converge. If this value here is greater than 1, it's going to diverge. When this value here equals 1, it's going to converge. So we require this to be less than 1, meaning we require this to be less than 1. So for convergence, we require this value here to be less than 1. So now as n tends to infinity, this block here will head towards 1. So for our series to converge, we require this whole thing here to be less than 1. Well, this thing here, as n tends to infinity, this thing here is going to be 1. So we can ignore this for the time being. So for convergence, we just need to require this to be less than 1. So let me take one step back. For convergence, we require the whole thing to be less than 1. But because the limit of this is going to be 1, then for this whole thing here to be less than 1, we just need to require this to be less than 1. You see, if this thing here is less than 1, then the whole thing here will automatically be less than 1 because the limit of this will be 1. So for convergence, we require this to be less than 1, meaning we just require this bit to be less than 1. So for convergence, we just require this. We just require this to be less than 1 for convergence. Okay. So now, well, from here you can translate it. Well, this whole thing being less than 1, you can translate it to this. Okay, so this thing here being between -1 and 1. So now divide everything by 2. That will then give you this, and then add 3. That will then give you this. So far, for convergence, we require this to be less than 1, meaning we require this to be less than 1. Well, so far, anything in between, uh, anything in this interval, we know that this is going to converge. Okay, so looking at this here, anything in between here and here, we know is going to converge. So anything in between 2.5 and 3.5, anything in between there, we know that this is going to converge. We now need to manually check what happens when it's dead on 5/2, and what happens when it's dead on 7/2. So because when it's 5/2, if you put it into here, this whole thing here will equal 1. And remember, when it comes to the ratio test, if this whole thing here equals 1, it's inconclusive. That's why we need to check this manually. And we need to manually check 7/2, because if you put 7/2 into here, this whole thing here will be equal to 1, which is inconclusive. So we need to manually check 2.5, and we need to manually check 3.5, which we will do in the next video.